They say that knowledge is power, and with the Ridgid SeekTech SR-60 cable pipe and sonde locator, you'll know more about the signal than with any other receiver. When tracing buried utility lines, the SR-60's signal readings show you the location, direction, and depth of locating signals, so you can acquire them quickly and easily trace their path. When locating duct probes and remote transmitters like the ones found in Sea-Snake camera systems, the SR-60's on-screen map helps you quickly and precisely pinpoint the transmitter's position and depth. Part 1 of this video will show you the basics of setting up and operating the SR-60's features, and show you how you can use those features to trace buried conductors. Part 2 of this video teaches you how to locate remote transmitters. The SR-60 operates on 4 C-sized batteries. To install the batteries, locate the battery compartment on the bottom of the receiver and turn the locking knob a quarter turn to release it. Install the batteries with the correct polarity as shown on the label inside the battery holder. You can use either alkaline or rechargeable batteries, but to prevent damage to the receiver, never mix rechargeable and standard battery types. When you've loaded the batteries, slide the holder back into the receiver and turn the locking knob a quarter turn to secure it. The batteries are installed, so let's power up the receiver and take a look at its interface and controls. The power key is located at the bottom right of the keypad. We'll press it, and after a few seconds the operating screen will appear, which means the receiver is ready for use. Let's start with a look at the display. The display has 2 main regions, the area outside the circle and the area inside the circle. The area inside the circle is called the active view area, and it's used to display the graphical locating elements and operating menus. Outside the active view area, we'll find indicator icons and numeric readouts. Some of these items will change depending on whether you're tracing a line or locating a sonde, so we'll cover most of these items in later segments. For now, let's look at just 2 of them. In the lower right portion of the display, you'll find the battery indicator. The icon will be completely filled in when the batteries are new, and will gradually empty as the batteries become discharged. On the left side of the display, you'll find the operating mode and frequency indicators. The number tells us the receiver is set to 33 kHz, and the icon tells us that this is an active line tracing frequency for use with a transmitter. You can select a different operating mode or frequency by pressing the frequency key. You can use the key in 2 ways. A short press cycles you through the frequencies one at a time. A long press opens a list, and you can use the up or down keys to scroll directly to the frequency you want. When the selection you want is highlighted, press the select key in the center of the keypad to choose the frequency and close the list. You can customize the frequency list by adding or removing frequencies. You'll do that in the main menu, which you can open by pressing the menu key. The main menu contains a list of frequencies. Each one has a box next to it. If the box is checked, the frequency is enabled, which means it will appear on the list that pops open when you press the frequency key. If the box is unchecked, the frequency is disabled and will not appear in the list. To enable or disable a frequency, use the up or down keys to highlight it, and then press the select key to check or uncheck its box. If the frequency you need isn't listed here in the main menu, you can easily add it, and your operator's manual contains instructions on how to do that. If we scroll down past the list of frequencies, we'll find some tool settings. The first item lets us switch the depth measurement between feet and meters. Just press the select key to switch back and forth. The next item controls how the LCD's backlight works. It's on automatic right now, which works well most of the time. You can also turn it on all the time or off all the time to save your batteries. Right below the backlight setting is the auto shutdown control. This feature turns the receiver off automatically if no keys are pressed for 1 hour. Press the select key to enable or disable this feature. The next item down lets us change the display's contrast. Press the select key to open the control, and then use the frequency and power keys to adjust the screen's contrast. When you're done, press the Select key to close the control. The final three items let you add or remove display features, add or remove frequencies from the main menu, and program in custom frequencies for use with other manufacturers' equipment, and reset the receiver to its factory default settings. Refer to your operator's manual for details on these menu items and how to use them. To exit the main menu, press the Menu key. There's one more key we want to look at here, and that's the volume control key. The volume control key lets you adjust the sound level coming out of the speaker. Press the key to open the sound menu, and then use the up or down keys to change the sound level. The menu will close on its own after a few seconds, or you can press the Select key to close it immediately. In this segment, we'll cover the SR-60's main display features and show you how they help make line tracing fast and efficient. Let's start with a look at how the receiver picks up signals from a target utility. In this sample circuit, a transmitter is directly connected to the utility. When the transmitter is activated, it generates an alternating electrical current that flows through the conductor and back to the transmitter through the earth ground. This current flowing through the conductor produces an electromagnetic signal that can be detected by a receiver. When designating a utility's position, it's important to understand that the receiver is actually tracing this signal and not the utility itself. You are assuming that this signal accurately indicates the utility's location below ground. In favorable conditions, this is generally true. Quite often, however, conditions exist that interfere with or distort the signal, which can make the signal readings less reliable. Some common sources of distortion are signal bleed onto adjacent conductors, turns, tie-ins, and large metal objects such as manhole covers, vehicles, and fences. The SR-60's 5 main signal readings help you spot signal distortion quickly. Because all 5 readings are available on screen while you locate, you can quickly compare them to determine whether or not the signal is reliable. Let's take a look at these signal readings and see how they work. We've connected a SeekTech ST33Q line transmitter to the tracing wire for a gas line, and we've set its frequency to 8 kHz. Our technician will position himself near the target utility, and we've marked the utility's position to make it easier to see. His receiver is on, and it's set to 8 kHz active line trace, so let's look at his display. We'll start with the tracing line and the left-right guidance system inside the active view area because you'll use these most often when tracing a line. The tracing line represents the signal's estimated location and direction relative to your position and operates independently of the other display elements. The tracing line makes it easy to acquire the target signal. Simply move the receiver until the tracing line is centered on the crosshairs. The tracing line tracks the signal in real time. You can move to the right, to the left, and even rotate the receiver, and the tracing line will continuously track the signal's estimated position and direction. The tracing line also helps you see signal distortion. Here's how it works. The tracing line's position and direction is based on the angle of the signal passing through the lower antenna, and its sharpness is based on the angle of the signal passing through the upper antenna. If the signal looks the same to both antennas, the tracing line will be sharp. But if the upper and lower antennas see the signal differently, the tracing line will appear fuzzy or distorted to warn you. Next, we'll look at the left-right guidance system. This display element is independent from the tracing line and has 2 parts, the guidance arrows and the guidance line. When you move the receiver across the signal, the guidance arrows track the signal in real time, pointing in its estimated direction. And when you're directly over the signal, the arrows will point inward to the center of the display. The guidance line serves 2 functions. First, it's a visual aid that helps you see where the guidance arrows place the signal's estimated position. Its second function is to help you align the receiver with the signal, because unlike the tracing line, the guidance arrows are measured with highly directional antennas that are most accurate when they are aligned with the signal. the guidance line changes length to indicate your alignment. It will be longest when your alignment is best, and will shrink as you become less aligned with the signal. When you're too far out of alignment, rotation arrows will appear to help you get the receiver back in alignment. We've seen what the tracing line and guidance arrows are and how they behave, so let's take a look at how you would use them to trace a signal. We'll start by using the tracing line to find the target signal and position ourselves over it. Then we'll align the receiver with the signal. We'll begin our trace by walking in the direction indicated by the tracing line. The utility makes a turn after just a few feet, and the tracing line will reflect that turn by rotating. We'll just keep the tracing line roughly centered and let it guide us around the turn. We'll continue, keeping an eye on the tracing line and guidance arrows. Both should be roughly centered at the same time, and the tracing line should look solid, not fuzzy. Let's stop for a moment and evaluate the signal. Take a look at the tracing line. Is it solid or fuzzy? Are the tracing line and guidance arrows both centered at the same time? Do they track with one another as we sweep across the signal? In this case, the appearance and behavior of the tracing line and guidance arrows indicate that the signal is trustworthy. Now that you've seen the graphical screen elements, let's take a look at our numeric readings, the proximity signal and the signal strength. The proximity signal is based on your distance from the signal source. The shorter the distance, the higher the number. The signal strength indicates the signal's absolute strength. The stronger the signal, the higher the number. Both numbers will be highest when you're directly over an undistorted signal and will decrease as you move away. Keep an eye on the two signal readings as we move to the right of the mark and then to the left. In this case, both numbers decrease when we move to either side and are highest when we're directly over the mark. Because both numbers are highest at the same point, this means they're both locating the signal source at the same topside position. They're also in agreement with the tracing line and guidance arrows, which means that we have 4 separate elements in agreement with one another. That's a good indication that our signal is trustworthy and not distorted. The final item we'll look at is the depth reading at the bottom left of the screen. The depth reading is the estimated distance from the lower antenna housing to the signal source. The reading will be lowest when you're directly over an undistorted signal, with the receiver held vertically and the lower antenna resting on the ground. The depth reading is a useful tool for evaluating locates, but the only way to verify the utility's actual depth is to physically expose the line. In Line Trace Basics, we showed you the fundamentals of operating the receiver and using it to trace a signal. In this segment, we'll demonstrate some advanced tips and techniques that will help you get more out of your equipment. Here's a technique that can help you evaluate a signal for distortion. We'll demonstrate this technique using the same location and connection point we used in Line Trace Basics. We'll acquire the signal, center the tracing line, and align the receiver with the signal just as we did before. There are a few basic questions we want to ask as we look at the display. First, is the depth reading in a reasonable range for this utility at this location? Is the tracing line sharp? Are the tracing line and guidance arrows centered at the same time? When we sweep across the target signal, do the tracing line and guidance arrows track smoothly? The depth does seem reasonable for this location, but the tracing line is a bit fuzzy. The tracing line and guidance arrows moved smoothly across the screen, but they're not centered at the same point. So it looks like we definitely have some amount of distortion. We're close to the transmitter's leads, and the line turns after just a few feet. Both of these things are sources of interference, so we'd expect to see some distortion. To get a feel for how much signal distortion we're dealing with, we'll look at where our display readings place the signal's location. We'll start with the guidance arrows. In this case, we can center them by moving the receiver just a few inches, which is a good sign. Next, we'll focus on the proximity signal and the signal strength. We're looking for the point where each reading is highest. We're also looking for agreement between these two readings, and between these readings and either the tracing line or guidance arrows. These readings agree with each other and with the guidance arrows, which means we have three independent readings that are in substantial agreement with each other. As a final check, we'll lift the receiver by a foot or so to see if the depth increases by the same amount, which it does. Let's summarize what we've just observed. Three of our signal readings largely agree with one another. The fourth is only off by a small amount. And when we raise the receiver, the depth increases by an appropriate amount. Based on these observations, we can conclude that the signal is only mildly distorted. If we were marking this utility, we'd first try to minimize the signal distortion. If we couldn't, we would base our marks on the three readings that agree. When the utility you're tracing makes a sharp turn like it would at a T or an elbow, the signal can become distorted at that point, causing the tracing line to lead you outside the utility's actual path. This effect can vary, but you'll generally find that it's more pronounced at higher frequencies, and on sharper turns rather than on sweeping turns, which can often be traced normally. Here's an easy technique for marking sharp turns. As you approach the turn, the tracing line will rotate significantly. This is a good indication you're dealing with a sharp turn rather than a sweeping turn. Let the tracing line guide you around the turn. Once you're past the turn, stop and pinpoint the signal with the guidance arrows, proximity signal, and signal strength. Dot the line, and then go back and get the other side of the turn using the same technique. To mark the turn, find the point where the two legs of the line intersect. The SR-60 sophisticated audio system provides feedback to help make locates fast and intuitive. The audio pitch is tied to the proximity signal. It increases when the proximity signal increases and decreases when the proximity signal decreases. The audio clarity reflects signal distortion detected by the tracing line. When the tracing line appears sharp, the audio will sound clear. When the tracing line is fuzzy, the audio will contain static. The guidance arrows also have special audio tones associated with them. When the signal is on your right, you'll hear the normal audio tone. When the arrow passes over the crosshair, you'll hear a double beep. And when the signal is on your left, you'll hear a pinging tone along with the normal audio. These tones let you work without having to keep your eyes glued to the display. When using the SR-60's Sound Pointer stereo speaker system, the sound fades to the left or right to reflect the signal position indicated by the guidance arrows. The speakers clip right to your safety vest and greatly enhance the receiver's audio capabilities. See your operator's manual for more information on using these speakers. With the SR-60, you can follow a signal's path even when you're not directly over it. Just point the receiver's mast towards the signal and keep the tracing line roughly centered on the display. Now you can follow the signal's path safely from the curb and only step into the street when it's safe to do so you can verify the signal and place your marks. In addition to tracing signals that are actively applied with a SeekTech transmitter, the SR-60 can trace passive signal energy that originates from sources like power lines, radio and television broadcasts, and electronic devices. Passive locating is generally regarded as a last resort means of locating a line and is often used to conduct blind sweeps of an area when there are no topside indications that a utility may be present. Passive tracing with the SR-60 is easy. You'll use the same signal readings as you do for active signals, and they work the same way. The SR-60 has two types of passive locating modes. The passive power mode can be used to locate the narrow range of frequencies produced by power transmission lines. Simply select 60 Hz power mode from the frequency menu and you're ready to go. The SR-60 has several different frequency options for power mode. For details on these options, refer to your operator's manual. The second type of passive locating mode uses patented broadband technology to search for signal energy within a range of frequencies. The SR-60 has three broadband ranges. The lowest range covers frequencies below 4,000 Hz, and the two radio frequency, or RF ranges, cover 4,000 to 15,000 Hz, and 15,000 to 35,000 Hz. The SR-60 also has a special broadband mode called OmniSeek. When set to OmniSeek, the receiver will search for signal energy in all three broadband ranges simultaneously and display a tracing line for each range that has a usable signal. The signal range that's closest to the receiver takes precedence. The range will be displayed above the OmniSeek icon on the receiver's display, and the bold tracing line and other display readings will reflect that signal. With OmniSeek, blind searches are fast because you're looking at all three broadband ranges simultaneously. When you see evidence of multiple signals, you can switch to the individual broadband ranges and trace each one separately. After performing an active locate, you can use the SR-60's OmniSeek passive mode as a final check to see if additional utilities may be present. In this example, there are pre-existing markouts for a phone line just to the left of the power and gas lines. So as a final check, he'll switch to OmniSeek mode to see if he can pick up the line. He picks up a signal just a few feet to the left of the other marks. The signal is in the high RF range, so he'll switch to that range and begin tracing the signal. The signal is solid, and he's able to trace it right up to the building. By gaining access to the building, he's able to energize the phone line with an active signal and then perform an active trace through the locate area to verify its position. In the past few minutes, we've shown you how the SR-60's main display features operate and how they can help you evaluate the signal and trace its path. To get the most out of your receiver, be sure to read the operator's manual before using the receiver on a job. The operator's manual contains information not included in this video and will help you obtain greater efficiency and accuracy with your receiver. And always remember that no matter how good the signal looks, you can never be certain of the utility's location and depth until you expose it. If locating remote transmitters such as duct probes or sondes is part of your job, be sure to watch the sonde locating segment